Hello and welcome to another episode of Maths with Mrs. Banks, where we make maths fun and easy to learn. And in this video, we're going to focus on trigonometry for mathematics grade 11, and this is part 1 of a 5-part video series. And in this part, which is part 1, we're going to focus on the CAS diagram. On that note, please don't forget to click the subscribe button and hit the notification bell so you don't miss out on part 2 all the way to 5, and more videos will upload in the future. Now back to the video. In summary, in this video, we're going to look at number 1, the basic trigonometric ratios. A lot of people are not sure who is who in the trigonometric ratios. So why we express this as such, we're going to clarify all of that in this video. Number 2, we're going to look at special angles and how they become important and how to use them whenever you are required to evaluate any of the trigonometric ratios without using a calculator. Number 3, we're going to look at the CAS diagram and we'll see exactly who the CAST stands for and who is positive where and how you determine that. Number 4, we're going to look at examples from past exam papers so you can see in an exam or test situation how this type of questions will come out. Let's start. First, let's look at basic trigonometric ratios. By now, you should know your basic 3, which is your sine, cos, and tan. We've got another set, which is what we call the set of reciprocals. Now, those who are not studying the IEB type of exam for may not necessarily encounter your reciprocals, but those who do, this is how you figure out who is who in the reciprocal and who is the reciprocal of who. The sine of theta, we express that as y over r. Now, y is simply the opposite in a right angled triangle, and I'm gonna give you an example on how to. Let's look at these special angles. We're jumping up and down, but I just wanted you to see now what is y. Y is the opposite of that angle theta. In this case, this angle is 30 degrees, so the opposite of 30 degrees is simply 1, because that's the side opposite the angle. Now the side adjacent to that angle is square root of 3, and then the hypotenuse is the same regardless of which perspective angle you're using to figure out what you're looking for. Now I just wanted to use this as an example so you could understand that this y is not just any y, it is the side opposite to that particular specific angle we're particularly looking at that moment in time. Now you've got the hypotenuse, which is represented by r, and then you've got your x, which is the adjacent. It represents the adjacent side, in other words, the side next to that particular angle. Now we've got this. Sine is expressed as opposite over hypotenuse, which is y over r, and then you've got cos expressed as adjacent over hypotenuse, which is in short x over r, and then you've got the tangent of theta, which is expressed as opposite over adjacent, which is y over x. Now the reciprocals are basically your trigonometric ratios over 1. I mean, like not over 1, but under 1. So for example, the cosec of theta, which is the reciprocal of sine, is simply equals to 1 over sine of theta. So whatever ratio you have on your sine, to calculate the cosec of the same angle theta, all you do is you flip your y and r upside down. That's how reciprocal works. Now the reciprocal for cosec, for cos of theta, is sec, and that's r over x, or 1 over cos theta. The reciprocal for tan is cotangent, which is just flipping it upside down. That's 1 over tan of theta, which is basically x over y. Now we're done with reciprocals. Let's look at cofunctions. Now cofunctions are those trigonometric ratios that are linked to a particular trigonometric ratio, but starting with the telltale word co. Now let's look at the full names of these trigonometric ratios so you understand where the co comes from. Now sine is simply sine with e at the end. We shortcut that as sin, right? But the full name is sine with an e at the end. Now sine has a cofunction, and the cofunction is one of the ones that we're so used to using, that is cos. Cos is short for cosine, so therefore Cosine, which happens to be cos, is the co-function of sine. Now, tangent, which is the full name for tan, tangent has got a co-function as well, and that function is cotangent, abbreviated cot, C-O-T. We abbreviate that as cot. Now the last one, which is secant. Remember, secant is the reciprocal of cos. Secant is the co-function, has the co-function cosecant. So cosec, which is short for cosecant, is the co-function of sec, and vice versa. So cotangent or cot is the co-function for tangent, and tangent is the co-function for cot. Same story. Sine is the co-function of cosine. Now these are going to be apparently important when we start with the reduction angle formula, which will definitely be video number 2. Now next, let's look at other identities that we work with that you need to know. The first one is what we call the quotient identity. In other words, your tangent of theta can be expressed as sine over cos. And then you've got the square identity, which is simply that the square of sine plus the square of cos for that same angle is equal to 1. Now you can take your calculator and use your calculator to calculate and figure it out for yourself, but you will see and find out that these are true, have been held true for a long time. Now next thing, number 2, let's look at special angles. We've already looked at this one. We've got 2 triangles, which are both right angle triangles. The first one is a scalene right angle triangle, and the second one is the isosceles right angle triangle. Scalene means that none of the sides are equal, which is the first one. In this one, isosceles meaning that you've got 2 sides that are equal, and also the base angles are also equal. Now these are used when usually they say to you evaluate without the use of a calculator. Now for example, to find the cosine of 30 degrees, you've got these special angles. The special angles are your 30, 60, and 45. These are your special angles. 90 degrees and 180 and 360. They're also special angles, but those are more special when we look at this from a reduction angle formula perspective. Now, how do we use these special angles? It's very easy. The cos of 30 degrees, for example, the cos of 30 degrees will be equal to, remember cos is x over r, which is adjacent over the hypotenuse. So what you do is you choose the triangle, the special triangle that has got the angle that you need to calculate. For example, this, in this case, 30 degrees. So this will be the triangle, the scalene one. Now here is the angle of focus, which is 30 degrees. Now we're looking for cos. That means the adjacent x square root of 3 over the hypotenuse. So that will be equals to 2 over, it will be equals to the square root of 3 over 2. And that's how you use special angles. Whenever you have a special angle and they say to you evaluate without using a calculator, you will need to have these triangles in front of you. Now they do give you these triangles, the special angle triangles, in the formula sheet at the back when you're writing an exam or a test. However, it wouldn't hurt for you to learn how to reproduce them. They're very easy once you get to know them. Next, let's look at the cast diagram. Now the cast diagram tells you which trigonometric ratio is positive or negative where, and that's what the CAST stands for. We're going to start with the first one. Now C is in the 4th quadrant. This is the first quadrant, number 2, number 3, and number 4. I know they're written, I just want you to have the numbers in front of you because it's easier to do that. Now first quadrant is between 0 degrees and 90. Second quadrant is between 90 and 180. Third between 180 and 270, and fourth is between 270 and 360. And then you go back to round and round indefinitely. Now the CAST means in quadrant 4, this, which is where we start with this lettering. That's where this stands for cos. Cos in the 4th quadrant is the only trigonometric ratio, and obviously it's reciprocal, which happens to be cosec. The reciprocal, yep, you should know the reciprocal. Let's go back. The reciprocal, of course, is sec, actually. It's sec. Sorry about that. All right. So that's where cos and its reciprocal, like I said, if you're not doing IEB, you don't have to worry about the reciprocals. But if you are going to write an IEB exam, this is important for you to know and understand how to figure out. So in quadrant 4, cos is the one that's positive. Everybody else is negative, meaning that your sine and your tan are negative together with their reciprocals. And in quadrant 1, everybody is positive. That's what the A means. It means all of the trigonometric ratios and their reciprocals are positive in the first quadrant. In the second quadrant, we've got S. That means only sine and its reciprocal are positive in the second quadrant. Everybody else is negative. In the third quadrant, same story. T stands for tangent, which is tan, and its cofunction, in its reciprocal, are positive. Everybody else is negative. So that's how you read the cos diagram. It's going to be very important in video number 2 when we use it to find the reduction angle formulae evaluations. Now let's look at an example that shows you basically how to use the cos diagram to figure out whatever it is that you want you to figure out. Now you're given a diagram here with a point, and the point has got the x coordinate and the y coordinate. You've got the x coordinate and the y coordinate. This one can form a right angle triangle. I just want you to see. So understand that whenever you have a right angle triangle, you're going to be using the theorem of Pythagoras. So you need to keep that in mind, which is very important in this particular case because that's what we are dealing with. The right angle triangle, which then gives you the ability to use the theorem of Pythagoras. Now, in this question, you've got your angle of focus, which is beta in this case. It's in the first quadrant, and that's why both your x and y coordinates are positive in that first quadrant. Determine the value without using a calculator of the angle beta. How do you do that? Easy peasy. So number 1A, to evaluate that, we're going to use those special angle triangles. So we're given that. Okay, now if you look at this, we've got x and y, right? Meaning that we can use the tangent of beta to figure out the angle easily. The tan of beta is y over x, which is equals to y is 2 root 3 over, and then we've got x is 2. Now that leaves us with square root of 3. Now to figure out what angle that will be, go back to your special angle triangles. Find the tan of the angle that gives you square root of 3 over 2. Let's go back to that. Square root of 3 over 2. And that is your y. The angle that your opposite is square root of 2. The opposite, the tan of that angle should be square root of 3. In other words, you can just square root of 3 over 1 or just square root of 3. Now, what angle is that? Okay, let's see. If you go 30 degrees, opposite 30 degrees, and adjacent will give us 1 over root 3. So that is not the correct one. Now, let's go to 60 degrees. The opposite of 60 degrees is square root of 3, and the adjacent is 1. Square root of 3 over 1 gives us square root of 3, meaning that, therefore, the angle is 60 degrees, and that's how you figure out this information using your special triangle. So using this special triangle, we find that therefore your beta is equal to 60 degrees. If you didn't want to use the special triangle and you wanted to use a calculator, that would still be cool. All right, using a calculator, this is how you would do it. Using a calculator, this is how you would do it. If you were to use a calculator, you would simply go beta is equals to 10 to the minus 1 of square root of 3. And then you take out a calculator. Let's go. Take out a calculator. 10 to the minus 1 of square root of 3. So you go 10 to the minus 1. So you go shift, then 10. And that will give you 10 to the minus 1. And then you go square root of 3. And then that will give you 60. There, 60 degrees. Make sure that your calculator is in degrees, not gradients or radians. You will get the wrong answer in a different setup. It's not wrong, but it will be wrong for the degrees that we are using. Next question, number B, goes, now find the cos of beta. We know that according to trigonometric ratios, the cos of any angle is equals to x over r. Now, from this one, we've got our x equals to 2. We've got our x equals to 2. And then we've got our y equals to 2 root 3. We don't have r. To find r, we must use the theorem of Pythagoras. R squared is equals to x squared plus y squared. And the reason Pythagoras, you must state the reason. You get marks for that. And then you'd use this to find the r. So let's go there. So step number 1, let's find r. Alright, let's find r. R squared equals to x squared plus y squared using Pythagoras. Alright, therefore r squared equals to, you substitute, always substitute first because you get marks for that substitution. Alright, now the x coordinate is 2 and the y coordinate is 2 root 3. Alright. Therefore, okay, let's go. So 2 squared plus 2 root 3 squared, that gives us 16. Therefore, r squared equals to 16, meaning that, therefore, r equals to plus or minus square root of 16, which is equals to plus or minus 4. Now, depending on the quadrant that the angle lies, right? It's in quadrant 1 in this case. Our x coordinate is positive, our y coordinate is also positive. R can never be negative, it has to always be positive. So R, just make sure that you are aware of that. R will always be positive, so your R will be 4. Now that you've got the value of R, what you do now is you use that to find the cos of beta. So we know that, therefore, the cos of beta equals to x over r, which is equals to, what is our x? Our x is 2 and our r is 4. 2 over 4, which gives us 1 over 2. And that's how you find that. Next, cos squared beta plus sine squared beta. We know that this is going to give us 1, but let's prove it for ourselves. Cos squared beta plus sine squared beta. This is supposed to, we know that cos is x over r squared and sine is y over r all squared. And that will be equals to, let's see, x is 2, r is 4, so that will be 2 over 4 all squared, plus y is 2 root 3, 2 root 3 over 4 all squared. Take out the calculator, right? You can even use just the calculations without using a calculator. In fact, let's do that without using a calculator so you can see for yourself. So we're going up here. All right, that is equals to, that is 4 over 16. 4 over 16 plus And that is 2 root 3 squared. So that will be 2 squared, which is 4, times square root of 3 squared is 3. So that is 4 times 3, which is equals to 12. So that will be 12 over 16, giving us what? So that will be equals to common denominator of 16, 4 plus 12. 4 plus 12 is 16, so that leaves us with 16 over 16, which is equals to 1. And that is us proving the square identity, which says cos squared beta plus sine squared beta equals to 1. There is the proof. Next, now let's look at examples from past exam papers. Now we're going to start with a simple one where you're given a diagram, and in this diagram they give you the information that you need. In this diagram below, point tx15, there it is a point in the Cartesian plane such that OT is equals to 17 units. Now that is your R, which is your hypotenuse. So from this information we know that R is equals to 17. Point P, which is got the coordinates negative 2a, lies on OT, the hypotenuse. K is a point on the positive x-axis, and angle TOK is equals to theta. There is K. Determine with the aid of the diagram the following, which is the value of x. Now how do we find the value of x? The value of x is the x coordinate of that point. We've got R, we've got y, and that is 15. That is the y coordinate of that point. They want us to find x. Now to find x, it's very easy. You use the theorem of Pythagoras. Now let's use the theorem of Pythagoras to find the value of x. So let's go 5.1.1. 5.1.1. So we use the theorem of Pythagoras. We know that r squared equals to x squared plus y squared. That is the theorem of Pythagoras. Now to find x squared, there are many ways you can. Therefore x squared equals to r squared minus y squared. Alright, okay, you can write it anyhow you want to. Alright, therefore x will be equals to square root of, what is r squared? R is 17, so that will be x 17 squared minus y is 15 minus 15 squared, and that is equals to, that gives us what? Okay, that's plus or minus, so that is equals to plus or minus. Take out a calculator. Let's go. Square root of 17 squared minus 15 squared, and that gives us 8. The square root of that is 8. So that is equals to plus or minus 8. Now, which one matches with the location of the angle? The angle is on the negative x axis, so therefore the x is the negative 1. X is equals to negative 8, and that's how you find the answer to that one. Now that we've got our x, y, and r, we can now easily find whatever trigonometric ratio they want us to figure out. Now the next one is tan theta. 5.1.2, tan of theta. Tan of theta is simply equals to what? Y over x. And in this case, our y is what? Our y is 15 and our x is negative 8. So that is 15 over negative 8, which is simply minus 15 over 8. And that's how you find that trigonometric ratio. Next, the cos of 180 minus theta, 5.1.3, 5.1.3. The cos of 180 minus theta. What you do here is you use your reduction angle formula. 180 minus theta lands us in the second quadrant. So you go 180 and then you go in acute angle back. So that lands you in the second quadrant, where only sine and its reciprocal are positive, but cos is negative. So that will reduce into negative cos of theta. We're going to do this in the next video in detail so you can see exactly how it all happens. So negative cos of theta, whatever our cos of theta is supposed to be. Remember, the trigonometric ratio for cos is x over r, so that will be negative x over r, and that is equals to negative, and then x is minus 8 over r is 17. And that is equals to positive 8 over 17. And that's how we find the cos of 180 minus theta. Look at the marks, they're not that much, so that's why this easy. Now let's find the square of sine squared theta. Sine squared theta is simply equals to x, it simply equals to y over r all squared. Now our y is what? Our y is 15 and our r is 17. So 15 over 17 all squared, and that is equals to, okay, take out a calculator. 15 squared, that is 225. Okay, that's the other one. 17 all squared, so that will be 225 over 289. 225 over 289, and you're done. Next one, the last one in this question is 5.1.5. It goes, find the value of a. Now the value of a is easy to figure out because notice that a is on the same hypotenuse. So whatever hypotenuse information you have for the t point also applies to the p point. What do I mean? We've got the x, we've got the y, we've got the r. So what we can do is we can use any trigonometric ratio, the one that's best to use because we've got all the information here, is the tangent. The tangent of theta in this case is equals to opposite over hypotenuse using t. The tangent of theta is equals to opposite over adjacent, I mean y over x, which is equals to 15 over negative 8. 15 over negative 8. But that is the same tangent of theta for the same point. So it will exactly be the same number even if we used our y in this point P and the x, the associated x. So meaning that this will be equal to y is a over x is negative 2. That's what it means. So therefore now you've got these two equated. So now we use that to find a. Therefore a will simply be equals to cross multiply. When you cross multiply, your a will be equals to negative 5 times 15, negative 2 times 15, sorry, over negative 8. The negatives cancel out, and then 2 goes into 2 once and into 8 4 times, and that leaves you with 15 over 4. And that's your answer, and that's how you answer this type of questions. Next question is going to be a little different, but still basically the same. And in this question, we're not given a sketch. We're given information and told to use a sketch to in the correct quadrant to determine or calculate the value of 1 plus 10 squared beta without using a calculator. So meaning that we will have to figure out a way to draw the cast diagram and where the angle is located. Now this is how you do it. First of all, let me give you a rundown and a breakdown on the best way to go about solving questions like this. So step number 1, this is what you do. Steps on how to evaluate trigonometric ratios without a calculator using the cast diagram. So number 1, you write the trigonometric ratio in its simplest form. Let's use the instructions. So we write the trigonometric ratio. Which trigonometric ratio? This one. This is the trigonometric ratio that we are given as part of the question, and we need to use it. So what we do is step number 1, we write this in its simplest form. So what we do is we take this to the right hand side, equals to positive 2. Now we divide both sides by negative 3, so we can get the trigonometric ratio, which is sine of b. Remember, sine is y over r. Y over r. Okay, we know that r is always positive. R is always positive. Positive. Meaning that therefore the negative bit here will be the y, which is at the top. Therefore the y is the negative 1. We're not sure yet what quadrant this angle falls, so we go to the next bit. Here is the next part. We look at the restrictions given to us. Let's go back to the instructions and steps on how to use the sign, which is plus or minus, and restrictions given to locate the quadrant. All right, what does the sign mean? We've got our sign is negative here. Our sign is negative, right? So we need to find where the sign is negative, number 1, and number 2, and that angle must be between 0 and 270 degrees, and that is 1, 2, 3. This is the bit. It must be in either quadrant 1, quadrant 2, or quadrant 3. Now, in quadrant 1, all trigonometric ratios are positive. All right. In quadrant 2, sine is positive. And in this case, this sign is negative, meaning that in these 3 quadrants, we're going to have to locate a quadrant where sine is negative, and that quadrant is quadrant 3. So this is where the angle will be located. This is where the angle is located. And look at the value of y. Y is negative 2, and that matches. It's below. So according to that, we know that the hypotenuse is 3. R equals to positive 3. So the hypotenuse is 3. The hypotenuse is 3. And the y coordinate is negative 2. We don't know what the x coordinate is yet. All right. So this is what we do. Step number 3. Use the quadrant to find x, y, and r. Okay, there we located the quadrant where the point is located based on the information given and the restriction. It's quadrant number 3. Now we know that our y is negative, so therefore y will be equals to negative 2, and the hypotenuse r is always positive, so it will be 3. All right, now use the Pythagoras to find the missing value. It could be x, y, or r. In this case, we've got y and r. From the information, we need to figure out what x is. Okay, to find x, use Pythagoras. R squared equals to x squared plus y squared. Let's substitute. Therefore, r squared minus y squared equals to x squared, meaning that r is 3, so y is negative 2, so 3 squared minus negative 2 all squared equals to x squared. Now therefore, therefore plus or minus will be equals to x. So let's use the square root, plus or minus the square root of 3 squared minus negative 2 all squared. Okay, use a calculator. Makes life so much easier. So let's find the square root of 3 squared minus negative 2 all squared, and that gives us the square root of 5 there. So that is plus or minus the square root of 5. Therefore, plus or minus the square root of 5 is x. Now, x in quadrant 3 is on the negative. Therefore, the correct value of x is the negative 1. Negative 5. Now that we've got our x, our r, and okay, therefore y equals to, and r equals to 3. Y equals to negative 2. So we've got all our x, y, and r. Now we can calculate whatever ratio they want us to evaluate. Okay, there is the sketch. We got the sketch. There we go. Now the value. Now determine the value of 1 plus 10 squared beta. Therefore, 1 plus 10 squared beta will be easy to evaluate. That will be 1 plus 10 is what? Y over x all squared. Alright, so therefore that is equals to 1 plus y is negative 2, x is negative square root of 5. So that's negative 2 over negative square root of 5 all squared. Alright, they'll end up positive, so that is y plus 1 plus 4 over 5. Use a calculator. That will be 5 plus 4, and that leaves us with 9 over 5. Can use a calculator though. 1 plus 10 squared beta, so that will be 1 plus open bracket, common fraction button, that is negative 2 over minus square root of 5. And then all that is squared. And there is the answer. It gives us 9 over 5. That is the correct answer. You can leave it as 9 over 5. You can leave it as 1 and 4/5. That's fine. That's up to you. So that'll be 5 goes into 9 once and leaves a remainder of 4 over 5. So you can leave it anyhow. That's fine. And that's the answer to that question. That's what happens when you do not have a diagram given to you like in the first example. Next example is like the first one. In the diagram, you're given a diagram here. In the diagram, point P, which is the goal, the coordinates negative 7k, is a point in the third quadrant such that OP, which is the hypotenuse, equals to 25 units. Now here you already have the information given to you. The x coordinate is negative 7. The y is your k, right? And then your r, which is the hypotenuse, is given to you is 25. You've got this information. It will make it easy for you to figure out whatever they want you to evaluate. Now the question is determine the value of the following. Okay, let's determine the value of k. The value of k is very easy to find. We just use the theorem of Pythagoras to find the missing value. So 3.1.1 r squared equals to x squared plus y squared. Now k is y squared, therefore, okay, let's substitute. Substitution is important because they give you marks for that. So always make sure you substitute first before you work the answer out. So 25 all squared equals to x is negative 7. There it is. Negative 7 all squared plus, and the k is k squared. Now let's find therefore k squared will be equals to, therefore 25 all squared minus negative 7 all squared will be equals to k squared. Alright, therefore plus or minus square root of that will be k. K will be equals to that. So let's take out a calculator. Square root of 25 squared minus negative 7 all squared, and that gives us 24. The square root of that gives us 24 plus or minus 24. Now let's go back to the quadrant where we are. Now y is negative in quadrant number 3, which is where the point and the angle are located. Therefore, the correct value for k will be the negative 24. And that's how you find the answer to that. Next, find the tan of theta. We've got our x, y, and r. Okay, there. K equals to negative 24. So we've got our x, y, and r. Okay, finding tan will be easy. 3.1.2. The tan of theta is equal to y over x. Our y is negative 24 and our x is negative 7. Negative 24 over negative 7, which leaves us with 24 over 7. And that is your answer there. Next question, the sine of 360 degrees minus theta. Here you use reduction angle formulae. We're going to do that in detail next video, but I'm going to show you how easy it is to work that one out. Sine of 360 degrees minus theta is simply equals to 360 minus theta is in the fourth quadrant because that's 360, and then you go back an acute angle back. That lands you in the fourth quadrant. In the fourth quadrant, sine is negative, so that is reduced to negative sine of theta. Negative sine of theta is simply equals to minus sine is y over r minus, okay, our y is negative 24, our r is 25. So that will be minus negative 24 over 25, which leaves us with positive 24 over 25. And that's how you answer that question. Easy so far. Very easy when you know what you're doing. We're back to the same type of example where you will need to follow that guide. We are given that 4 tan of beta plus 5 is equals to 0. That's our cue there. That's our clue. All right. And beta is between 0 and 180. Clue number 2. So that's clue number 2. Clue number 2. And that's clue number 1. Alright, according to the rules, remember the rules. Let's go back to the rules if you need to go to the rules. Step number 1, write the trigonometric ratio in simplest form. That's step number 1. Let's write this in simplest form. So we go 4 tan of beta plus 5. 4 tan of beta plus 5 equals to 0. And let's simplify this. Let's simplify this. Therefore, 4 tan of beta equals to minus 5. Now we divide both sides by 4. Tan of beta will be equals to negative 5 over 4. So we're looking for where tan is negative. Remember, tan is y over x. We're looking for where tan is negative. Tan is negative. That's what we're looking for. That's the quadrant we're looking for. Okay, we're looking for where tan is negative, number 1, and where it's between 0 and 180 degrees. Between 0 and 180 degrees means it will either be in the first quadrant or the second quadrant. Now we're looking for where tan is negative. In the first quadrant, tan is positive, just like with all your trigonometric ratios. So therefore, the only quadrant within this interval they've given us will be in quadrant 2. That's where tan is positive. Tan is negative. Therefore, beta is in quadrant 2. Now you can draw a small, I'm just lazy to draw this again, so you can just draw that diagram. And then we go, all right, so this is the diagram. Okay, so for what information do we have? Our y. So in this quadrant, notice that Y is on the positive because it's above the x-axis. It's the x that's on the negative. So therefore, your y is positive and your x is the negative part. Okay, the x is the negative 4 and then your y is the positive 5. That's how you figure that one out. You take that quadrant where the angle falls and then you see whether your y is positive or not and whether your x is positive or not. In quadrant 2, x is on the negative side, so your x coordinate will be the negative 1 and your y is on above the x-axis, meaning that it will be the positive 1. Now from that, immediately we can calculate r. So we've got those three figured out, right? Next, we use the quadrant to find x, y, and r. We've done that. Okay, used Pythagoras to find the missing value. So we used the theorem of Pythagoras to find the missing value. R squared equals to x squared plus y squared. That's Pythagoras. Now you must substitute. Therefore, r squared equals to plus y squared. So it will be negative 4 all squared plus positive 5 all squared. Therefore, r will be equals to positive. Remember, r can never be negative. It will always be positive. Take out a calculator. Let's figure that one out. So that's the square root of negative 4 all squared plus 5 all squared. Square root of negative 4 all squared plus 5 all squared. And that gives us the square root of 41. So that gives us the square root of plus minus, okay, the square root of 41. Therefore, r equals to the square root of 41. Now we can calculate the value of 41 cos of b. Therefore, square root of 41 cos of beta is equals to, remember, cos of beta is equals to x over r. So that will be square root of 41 times x over r, which is equals to square root of 41. X is negative 4, and then r is the square root of 41. The square root of 41s cancel out, and that leaves you with negative 4. And that is how you calculate and evaluate without using a calculator, but definitely using the aid of a diagram and your trigonometric ratios. Thank you so much for watching. We'll come to the end of this video. I'll see you in the next one. Bye-bye.